Hello and welcome to Team 1's interim presentation. Our chosen product for redesign is a manual pasta maker. Our names are Ethan Vanderoost, Jaden Manisto, Oscar Roden, Quinn McIntyre, Sean Delaney, and Tate Matthews. Here's a bit of background information about the product. A pasta maker consists of several key components: a sturdy frame, adjustable rollers, interchangeable cutting attachments, and a crank handle. The rollers, which can be set to various thicknesses via a gear mechanism, flatten the dough uniformly as it passes through. Users turn the crank handle to actuate these gears. Once the dough is flattened, cutting attachments equipped with sharp blades slice the dough into specific shapes, such as spaghetti, fettuccine, or lasagna. The entire assembly is typically constructed from stainless steel, providing durability and ease of cleaning, as well as giving the device a professional appearance.
We estimate a production volume of about 50,000 units per year in the U.S. Our primary customers are personal home chefs who cook for themselves, friends, and family. They value handmade pasta but do not require a high yield or a high production rate. Our secondary customers are small businesses like cafes, personal chefs, catering businesses, and culinary schools that want to create homemade pasta for a larger quantity of people but do not have the demand of an industrial pasta machine.
This is our assembly and exploded CAD. We divided the assembly into two sub-assemblies due to the large number of parts.
Our first assembly sequence starts with the base, from which the case right is added, and then the turning shaft is connected to where case left is added. And then we build the cutter sub-assembly and add it to the back of our sequence. At the end, we add the turning handle, and then we have a completed assembly. Our secondary assembly sequence starts with case right. Then we add case left with the turning shaft, and then we add the base on the bottom. Then we build our cutter sub-assembly and add it to the back of our assembly. Then we add our turning handle, and we have our completed assembly. Based on our analysis of the sequence comparison, we decided that sequence 2 would be better for its ease of transferring and handling and ease of fastening and joining.
Here's our fast diagram outlining the basic functions and sub-functions of our pasta roller. The basic functions are roll pasta, cut pasta, prevent slip, assure dependability, assure convenience, enhance product, and please senses. Here's our FCMM for our pasta roller, outlining which parts relate to the sub-functions of the design. And here's the second slide of that because we have so many parts.
Here is the bill of materials for our first sub-assembly, the pasta cutter. This is the bill of materials for the remaining parts in the rest of the assembly. The total number of parts for this product is 31.
These are the manufacturing costs given to us by Hubs.com. The total manufacturing cost came out to $28.72 per unit, which makes sense given that the average pasta maker sells for around $80. These are the assembly costs. The assembly time was determined using the manual handling and insertion reference tables for each part. The total assembly time is the overall sum of each part's assembly time multiplied by the quantity of each part. The total assembly time is 255 seconds per unit, and the total assembly cost is $4.11 per unit. Here is the quad chart classification. In the low assembly cost and low functional importance section, there is the bolt and the inside case. In the high cost and low importance section, there is the handle plate, top plates 1, 2, 3, 4, and 5, the outside case, the vise handle, the inner cap, and the outer cap. In the low cost and high importance section, there are rollers 1, 2, 3, and 4, the gears, the large cutters, the thin cutters, the turning shaft, the turning gear, the turning handle, and the frame rod outside. In the high cost and high importance section, there's the inside roller guard, the outside roller guard, the blade guard, the frame rod inside, the base plate, the base block, the vise frame, the alignment frame, and the frame rod outside.
Based on the FAST, we create a function differentiation table. The functions that vary between the different customer groups include customization and enhanced portability. From the function differentiation table, we created a component commonality table with platforms and modules. The turning handle module corresponds to the customization function, and the vise frame and vise handle module correspond to the enhanced portability.
The first design for Home Chefs got rid of the vice grip at the bottom, replacing it with a larger base. This makes it more portable and easier to set up. The second design is for our secondary customers, small businesses. This design has a longer handle, allowing them to get more torque output to turn their pasta, allowing them to speed up production and turn a wider variety of dough. This is how the design assembly varies between the original and modified assembly sequences. The modified assembly sequence utilizes the same first 3 steps before diverging for base and handle assembly.